Hi everyone, and welcome back to another series of videos on chemistry revision. For today, we will be focusing on the type of questions that you commonly see in exam, which is qualitative analysis or QA, but flowchart type of questions, the kind where you have boxes that gives you lots of experimental results and then you have to try to figure out the unknowns. Okay, so I will be going through the thought process required to solve such problems. Now, a good start would be before you attempt such questions, you should have a very good understanding of the requirements for tests for cations, tests for anions, as well as tests for gases. Okay. In addition to that, it will be useful for you to know reactions involving acids and alkalis because they also come into play in such questions. Okay. So right now, let's tackle the first question. Okay. Figure 1 shows some reactions involving a salt P. Now we notice here that salt P is colorless. Okay, that actually already tells you some things. You can actually eliminate the colored salts. That means you can eliminate copper 2 plus, you can eliminate the iron 2 plus. Okay, so those are just some hints. Okay, so it tells you that you add acidified silver nitrate. Now, adding silver nitrate is usually test for the chloride ion. Okay, so testing for chloride ion, you get a white precipitate, which means chloride ion is present. Okay, because silver nitrate is used to test for the presence of the chloride ion. If chloride ion is present, you get a white precipitate, which means this is because this precipitate is insoluble silver chloride. Okay, remember all chlorides are soluble except lead chloride and silver chloride. So we know here automatically that chloride is present. Okay, so now let's continue. We add aqueous ammonia and we get the white precipitate R. Okay, we still don't exactly know what is this salt. It could be zinc, lead, aluminium that produces a white precipitate with aqueous ammonia. But you also get adding excess aqueous ammonia and it becomes a colorless solution. Now if you get a colorless solution, that means the precipitate dissolves in excess aqueous ammonia, and there is only one cation where the precipitate dissolves in excess aqueous ammonia, and that cation is zinc 2 plus. Okay, therefore zinc 2 plus must be present in the original P. Okay, now if zinc which matches up because zinc solutions are typically colorless. Okay, now if you add aqueous ammonia to a solution containing zinc 2 plus ions, the precipitate you get will be zinc hydroxide, okay, which is ZnOH2. Later we will revise the formula as well. Okay, now when you add zinc hydroxide and you add sulfuric acid, you get a colorless solution S. Okay, now this colorless solution S, if you think about it, zinc hydroxide reacting it with sulfuric acid. Now let me move this away a bit. This is actually Zn2 plus. If you react it with sulfuric acid, you will realize that this is actually a reaction between an acid and a base, which means you will get a salt and water. So what is the salt that I will get? If I add zinc hydroxide to sulfuric acid, my salt will be zinc sulfate and I will get water. So that means this solution here will be zinc sulfate. Okay, now that is also true because now you can see that I'm adding acidified barium nitrate, which you would remember is a test for the sulfate ion. Okay, and how do I know that the sulfate ion is present? When I get a white precipitate T. Now this white precipitate would be insoluble barium sulfate, because remember, all sulfates are soluble except calcium sulfate, lead sulfate, and barium sulfate. Okay, so we have managed to actually identify all my unknowns. Okay, so let's go ahead and identify the substances P to T. P was here containing zinc ions and chloride ions. So P is zinc chloride. Okay, the formula being ZnCl2. Q here was the white precipitate when we added the silver nitrate. So Q is silver chloride, and the formula for silver chloride is AgCl. Okay, what was R? R was the white precipitate after we added aqueous ammonia, and that will be zinc hydroxide. Formula will being ZnOH2. Okay, colorless solution S we have identified with zinc sulfate. Formula ZnSO4. And lastly, the white precipitate T was barium sulfate. Formula BaSO4. Okay, so here you can see that we have actually used knowledge on testing for chloride, testing for cation. We also learned to test for sulfate ion, and we also have an acid-base reaction. Okay, so you can see how all this information come into play when we solve such problems. Okay, so now let's go ahead and try to do a second problem. Let's try to see whether we can get more information, practice a bit more. The reaction scheme below shows the results of some experiments on a green crystalline solid. Now it says here we have green. Now green could indicate the presence of iron 2 plus. Maybe it could also be copper 2 plus, because some copper salts are actually green. Not necessarily all copper salts are blue. Okay, so that gives us some indication. Now it also says crystalline. Okay, so most likely this substance being crystalline is not a carbonate. Okay, because usually carbonates are not crystalline. Carbonates tend to be powdery. Okay, so now we go and see the first one. Dissolves in water and add dilute nitric acid and add silver nitrate solution, which again you will remember is a test for the chloride ion. And if the chloride ion is present, we will get a white precipitate. Therefore, we know that there is chloride ion present in the unknown green solid. Okay, and since we're testing it with silver nitrate, we know that the precipitate will be insoluble silver chloride. Okay, so we've already identified one of the unknowns. Okay, so now we move on. We dissolve in water and warm with aqueous sodium hydroxide. Now usually when we warm with aqueous sodium hydroxide, it is a test for the ammonium ion, because usually if we just test for cation, we don't really have to warm the solution. Okay, now if we warm with aqueous sodium hydroxide and we get a gas B that turns red litmus paper blue. Now this gas can only be ammonia gas. Okay, so ammonia gas is the only gas in your syllabus that turns red litmus paper blue. So that means if we get ammonia gas here, we know that ammonium ion is present in the green crystalline solid. Okay, so we also have the ammonium ion present in this green crystalline solid. Hey, wait a minute, does that mean that it is ammonium chloride? But that ammonium chloride is usually a white salt. Could it be? But why is this green? So let's take a look a little bit more, because that's not the full picture. We also get a blue precipitate with C. Okay, now this blue precipitate definitely indicates the presence of the copper 2 plus ion, because after all we are testing with sodium hydroxide, which is used to test for cation. Okay, so the cation Cu2 plus is present, and the precipitate we get here will definitely be copper 2 hydroxide. Okay, now when we add excess dilute sulfuric acid, we get a blue solution. Now, what is the reaction here? This reaction is essentially reacting copper 2 hydroxide with sulfuric acid. And again, in the previous question, we know that this is a reaction between an acid and a base. Okay, so being an acid and a base, the products we will get will be salt and water. Again, since we have sulfuric acid, the type of salt that we get is copper 2 sulfate, and water being the other product. So you can see here we have managed to actually find all the unknowns. Now, we get a blue precipitate here, indicates the presence of copper 2 plus. Where did this copper 2 plus come from? The copper 2 plus came from the green crystalline solid. So Cu2 plus was also present here. So what is this salt that contains the ammonium ion, the copper 2 plus ion, and the chloride ion? What's the name of the salt? Well, fortunately for us, we don't really have to worry, because we are not asked to identify the name of the green solid, but we are asked to identify everything else. So let's write down all the names of the substances A, B, C, and D. A, we have seen that A is the white precipitate, and we know that it is silver chloride. So let's write down A is silver chloride, and the formula for silver chloride is AgCl. B is the gas that turns red litmus paper blue, and we know that this is ammonia gas. Okay, we don't really have to write gas, we just write ammonia, and the formula is NH3. What is this blue precipitate C? The blue precipitate is copper 2 hydroxide. Therefore, we spell it out, copper. Now you must write the 2 here, copper 2 hydroxide, with the formula CuOH2. And lastly, the blue crystals here is the salt that we get from the reaction between copper 2 hydroxide and sulfuric acid, and that blue crystals will be copper 2 sulfate. And you should know by now the formula is CuSO4. Okay, so here you can see that several things that we would require to know. Again, testing for the chloride ion, testing for the cation, and testing for the ammonium ion, which is warming with aqueous sodium hydroxide. Okay, and we can also figure out, get a little bit of indication of the nature of the cation by the color of the cation itself. Okay, since we know that green typically indicates the presence of Fe2 plus or copper 2 plus. Okay, let's do one last question before we wrap up this first part. Okay, this one will be slightly different. So let's see whether we can figure out the unknowns. Figure 3 shows some reactions involving a white solid compound P, which contains the calcium ion. Here they already tell you it contains the calcium ion. So automatically we can write Ca2 plus up here. Okay. Now we heat it strongly and we get a white solid Q and a colorless gas S. Okay. Now what kind of gas can we get when we heat a solid strongly? Okay. Possibly, okay, we could get carbon dioxide as a possibility. Okay, we may even get things like nitrogen dioxide, but that's reddish brown, so that's not possible. We could possibly get oxygen as well if we heat a solid, but let's see whether we can figure out the nature of this gas. Okay, since we're not so sure, let us just erase all this first and don't confuse ourselves. Okay, now we heat strongly, we get a white solid and a colorless gas. Okay, now we add this white solid to water and we get calcium hydroxide. Calcium hydroxide has a formula of CaOH2. Of course, you would also remember that calcium hydroxide has a common name called lime water. Okay, now what could we have gotten, what could we have added to water to give us calcium hydroxide? Okay, and this white solid was obtained by heating a solid, a white solid P. Okay, so the only possibility here that is that Q is actually calcium oxide, because adding calcium oxide to water will give you calcium hydroxide. So this is calcium oxide. Now if we know that this is calcium oxide and we obtain solid Q from heating P, we should know that this should be calcium carbonate. Okay, and the gas that we get here would be carbon dioxide, because the decomposition of calcium carbonate when heated strongly gives us calcium oxide and carbon dioxide gas. Okay, now even if we're not sure, let us take a look and see whether or not we can get a bit more information from this side of the picture. Now we add an acid to a white solid and we get a gas. Now when we add an acid, there's two reactions that gives you a gas. Okay, let's write that down. Acid plus metal gives us hydrogen gas, and we know that acid reacts with carbonates to produce carbon dioxide gas. Okay, now from the question we know that this is a white solid, so it's not possible usually that the solid is a metal, because most metals are grayish or silvery. So therefore the white solid here should be a carbonate. Okay, and if this was a carbonate and we reacted with acid, we would get carbon dioxide. Okay, and since we are adding calcium carbonate to dilute nitric acid, we are reacting calcium carbonate and nitric acid, we should get a salt, and the salt will be calcium nitrate, and we get this gas as carbon dioxide, and we will get water. So to balance out the equation, we put a 2 there, which means this salt R is calcium nitrate. Okay, so now we have managed to identify everything. Oh, hang on, there's one more here. Calcium hydroxide added to sulfuric acid. What will be my white precipitate? Let's figure out. Calcium hydroxide, which is a base, and add it to sulfuric acid, which is an acid. So acid plus base will give you a salt and water. So what is my salt? I will get calcium sulfate and water in this case. Okay, and it says it's a white precipitate because we know calcium sulfate is an insoluble sulfate, just like lead sulfate and barium sulfate. So we have now identified all our unknowns. Let's go and list them down one by one. Q, where is Q? Q is the white solid here, and we know that Q is calcium oxide. Let's write this down. Formula CaO. R is calcium nitrate here. Let's write it down. Calcium nitrate. Formula Ca bracket NO3 2. What is S? S is the colorless gas, which is carbon dioxide. Let's write this down. Carbon dioxide, formula CO2. And finally, T, the white precipitate, is calcium sulfate, which is CaSO4. Okay, so again here we see that we need to know a couple of reactions. We need to know acid and carbonate reactions. We need to know acid-base reactions. We need to know what happens when a carbonate decomposes to give you carbon dioxide. Okay, and we again have we also need to know the solubility of salts. Okay, so I hope that this video has allowed you to get a basic understanding of how to solve QA flowcharts. Now, in the next video, we will be dealing with the same type of problems. However, we are adding certain other elements. Okay, for example, displacement reactions and redox reactions. So tune in for the next video. All right, see you soon. Bye-bye.